Water is the most abundant and available resource for combating fire. Its extinguishing properties are a function of the law of specific heat and the law of latent heat of vaporization, as well as of its surface area when applied in a specific gravity. In most applications, water's advantages as an extinguishing agent outweigh its disadvantages. The pressure and velocity at which water is applied also affect extinguishment. Friction loss plays a major role in water's effective application during firefighting operations. Municipal water supply systems are a major source of water for firefighting. Their primary components include a water supply source, a means of moving water, processing or treatment facilities, and a storage and distribution system. Private water supply systems may be used to replace or supplement municipal systems. The law of specific heat can be considered in similar terms as specific gravity of a material. It measures the amount of heat needed to raise a material a specified amount as compared to raising an equal amount of water to the same temperature. If a material has a specific heat rating lower than water, it will not absorb as much heat. The high heat absorption ability is what makes water a good extinguishing agent. The additional heat absorbed by water as it is converted to steam is another reason why water is such a good extinguishing agent. The smaller drops of water applied to a fire, the faster it will absorb heat and convert to steam. When the need arises to get water deep into a building through a high heat environment, this conversion of small drops to steam reduces the effectiveness of our fire stream. Therefore, we need to consider changing to a nozzle that delivers a larger chunk of water to the seat of the fire. A solid bore nozzle would be more effective in this situation. The important point to remember regarding specific gravity is that many flammable liquids have a specific gravity of less than 1. Flowing water onto a flammable liquid fire may allow it to spread as the fire floats on the water. This may also be the case if the runoff from firefighting efforts is allowed to carry flammable liquids away. While most of the disadvantages of using water as an extinguishing agent may be clear, surface tension may seem obscure. Surface tension prevents water from soaking into a material, preventing full extinguishment, leading to rekindles or continuation of burning as in wildland fires. Pressure is measurement of the force that moves the water through our systems. Sometimes it is from elevation, as you would get from a water tank, or it may be generated by a pump. Understanding the principles of pressure will be key to understanding hydraulics calculations later on in your career. Head pressure is pressure created by the atmosphere pressing down on water, or by gravity, or water stored above ground. Static pressure is the pressure in lines when the water is at rest, not moving. It may be created by atmospheric pressure, head pressure, or by a pump. Residual pressure is the pressure found in lines, or the system, while water is moving. Residual pressure varies depending on the amount of water flowing. As more water is taken off for firefighting, the lower the residual pressure in a distribution system. Flow pressure, or velocity pressure, is the pressure of water once it has left the orifice. Elevation is overcoming gravity when pumping uphill, or receiving increased pressure when water flows downhill to the pump. Altitude has a negative impact on pumper effectiveness at high altitude due to the reduced amount of atmospheric pressure on the surface of the water. The effects of altitude will be very negligible for firefighters working on a municipal water distribution system. Friction loss is directly related to line diameter, length, and the amount of water flowing through the line. A thorough understanding of friction loss principles, and more importantly how to overcome friction loss, is essential to operating lines effectively. Some of the causes of friction loss can't be controlled by the firefighter. Focus on those that can. Fire hose lining. You may not be able to control what the lining of your fire hose looks like, but you can lay the shortest line possible to meet the needs of the fire attack. Have adequate line, but not a bunch of extra. Hose coupling and pipe fittings. Hose couplings should be at least the same size as the hose that they are coupled to. Gaskets should be in good shape, not protruding into the flow. Use only the fittings and adapters that are required for the lay. Know your pumper. Knowing which discharges have many elbows or small plumbing or valves will help you extract the maximum amount of flow from your apparatus. Sharp bends. Lay lines as straight as possible, never allowing a hose line to flow with a kink in it. Kinks not only cause friction loss and reduce flow, they may even cause damage. If the fire which you are fighting is going to require that you extract the maximum amount of water from a line that can flow, consider using the next size up line. Increasing the line size is the easiest way to reduce friction loss. To overcome friction loss, consider the following. Length of the hose lay. The shorter the lay, the less friction loss for a given diameter line. Again, have an adequate amount of working line at the destination, not a bunch of extra. Amount of flow. If you need maximum flow from a line, go to the next line size up. This may mean laying a 2.5 inch line initially and reducing to an 1.5 inch line for finishing. Perhaps the initial call will be master streams at the flow requirement near the upper end of what you can flow with your 2.5. Remember, if you can't deliver enough gallons per minute to overcome the amount of heat generated by combustion, you won't put out the fire until it peaks and the fuel supply starts to become exhausted. If your friction loss problem is in your supply line, use a larger supply or lay parallel lines. Pulling 1,000 gallons per minute from a single 5-inch supply, the water has to move at a velocity much greater than it would to get 1,000 gallons per minute from two 5-inch supply lines. Increased velocity equals increased friction loss.